Hello, and welcome to this short webinar on the single engineering source solution from Da쏘si스템. During this webinar, we'll outline the business value delivered by this solution through its fully integrated design environment, an environment that optimizes the entire product development process through real-time concurrent design and collaboration across all stakeholders. Let's start by considering the business problems we're trying to address. Traditionally, engineering has used a very sequential and inefficient process that wastes both time and money and is characterized by individual engineers working largely in isolation on a given set of design data at any one time. This sequential process stems from the need to ensure that only one engineer was modifying a given set of design data at any given time. The control of this sequential process is usually enforced by some sort of data check-out, check-in mechanism, where one engineer would check out and lock all the data he needs to perform his tasks, complete his task, and then check all the data back in. This approach often results in complete assemblies being checked out for prolonged periods of time, preventing other engineers from modifying other parts of the assembly until it's checked back in. This sequential approach is further exacerbated when collaborating with globally dispersed organizations that use different systems and file formats. There's no single source of accurate information that all stakeholders can easily access and collaborate on in real time across all disciplines and organizations. With today's tighter profit margins and the need for speed in developing and customizing products, the demand for product development efficiency has never been greater. To achieve this efficiency, we need to optimize the complete product definition process from end to end. As an example of process optimization, consider the efficiency of a Formula One team during a pit stop at a race. From stopping the car, changing all 4 tires, refueling, and releasing it to continue the race can be achieved in less than 5 seconds. Every team member and activity is synchronized in perfect unison and speed around a common goal of getting the car back in the race as quickly as possible. If we apply this analogy of the race car to our design process, we need to optimize the complete design process by getting all stakeholders to work in parallel around a single shared product definition that can be leveraged by all disciplines and organizations in real time. The Da쏘si스템 single engineering source solution delivers this design process optimization capability. The solution is built on a powerful 3D experience platform that provides a single source of truth for all users. It puts rich 3D experiences at the heart of the product design process to allow organizations to imagine, engineer, and experience the most innovative and complex products. That platform unifies the global product development and lifecycle management process across the value chain. It provides comprehensive capabilities to manage the entire product development process and drive business intelligence through powerful data analytics and 3D dashboarding capabilities. These dashboards allow stakeholders to access all necessary product development information and to identify, solve, and track issues while allowing users to efficiently collaborate, navigate, and reuse assets across multiple products and their variants. Let's take a look at some of the highlights of this solution in the context of a short demonstration scenario. Consider a situation where an engineer, Cindy Jim, has been assigned a task from a project manager to modify a filling machine which is currently under development to ensure it complies with new noise regulations and standards. This task involves replacing the standard transmission with a silent one and modifying the housing by adding better acoustic panels to it. The scenario comprises of the following steps: review the task or work package, navigate and interrogate the current designs, modify designs, and collaborate with other stakeholders. Now let's look at each of these steps in turn. By opening the task, she quickly has access to the design specification document. It informs her that the new combi line is composed of 4 reused modules. She understands that the filling machine is the noisiest one and requires a new transmission and new housing panels. To speed up the process, the project manager has prepared the work as most of the modules are reused. An initial engineering BOM has also been assigned to the task. Reusing existing components helps reduce the development time and decreases the cost while improving the quality of the final product. By navigating the 3D mockup, you can review some key characteristics of the machine and obtain critical information. The compass indicates various states of information to understand what is reused. In blue, the 3 existing modules from existing projects. In green, what is impacted and will need to be modified. You can also understand the maturity levels. The green one can be modified, the others are either modified or frozen. You don't need to be an expert, everyone can do it, no matter where you're located in the world. Visual 3D navigation is extremely fast and helps to manage the increasing complexity of industrial equipment. It works just as well on very large assemblies with tens of thousands of parts. It allows better understanding and efficiency. 3D is the universal media. Now, using intelligent design in CATIA, you can change the transmission with a standard component from a catalog. 3D catalogs enable you to easily manage standard components. Each time you want to use a purchased component, you can choose only components validated by company rules. That way, you're always sure that standard components used in the design come from the right suppliers. After the replacement, a digital mockup review warns that all conditions at the level of the carousel space reservation are not fulfilled. The vertical motor clashes with the filling system. A quick measurement indicates that the filling system must be raised by 100 millimeters. Thanks again to intelligent components based on parameters and rules, new required geometry is quickly created. As a result, a shorter rod solves the problem. Now the drawing, the official document in the industrial equipment industry, is also available with the holistic bill of materials. All information mandatory to manufacture this assembly is displayed. Since the drawings are linked to the actual geometry, a quick update's all that's needed. The second modification concerns the housing panels. Before performing any other modifications, a typical question that always comes to mind is, are you sure you're working on the up-to-date data? You can quickly see the answer in red. Someone in the company has been concurrently working on the existing housing. Now you can easily replace this version with the most recent one. You've just seen how easily modifications could be applied. It's time now to validate and close the preliminary design task. By retrieving the project manager can validate, or not, the last task of the preliminary design phase. After checking the EBOM, all Cindy's modifications are accepted and the phase color chart turns to green. Before launching the next project phase, you can check that all required conditions are filled and the project can continue. Let's see how collaboration between 2 mechanical engineers, Julian Mallow and Cindy, is simplified. Julian is a mechanical engineer who's working on the same machine, and he is responsible for the tank. He has performed top-down navigation inside the complete machine and zooms on a subcomponent just by simple clicks. The tank of the rotary filler to be modified is quickly found and reserved for addition. Cindy is warned in real time that a colleague is working on the same assembly. With the simple color coding, she is informed of the components that are being changed, so she understands that the tank will have a new shape and which colleague, Julian, to contact in case of an impact on her job. Julian decides to improve the quality of the tank by adding a window. This will allow a visual check of the liquid level when the combi line will be in production. After performing this modification, Julian saves it to propagate the modification in the database. Now you can see how Cindy is able to retrieve Julian's updates. The yellow color shows you which components have been modified, and a simple click on it enables you to load and refresh the session with the latest modifications. With only a simple save operation in CATIA, the modification is taken into account in the assembly. Collaboration between engineers is fast and easy. Working in a secure environment with suppliers is just as easy. In a dedicated collaborative space, a secure environment, you can upload only the specifications and the project data that the supplier needs to validate, controlling your intellectual property. After receiving all the information, the supplier can confirm the data and simulate that the mechanism will be robust enough to support the weight of the new bottle when filled. To summarize, Da쏘sistems' single engineering source provides increased productivity, competitiveness, and product differentiation for increased speed, reducing time to market by up to 50%. There's also reduced cost and risk with reduced development cost, increased product quality, reduced risk of product failure, protection of existing investment in tools and processes. Lastly, the additional efficiencies include the ability to accelerate collaborative innovation, reduced errors and improved design accuracy through instant access of updates from others, increased engineering efficiency by eliminating data synchronization between sites, the ability to ensure and demonstrate regulatory compliance. Thank you for watching this webinar on Single Engineering Source, and hope you found it valuable and informational.